Alright, chapter 20, problem 36. We have a copper wire with resistance of 0.5 ohms at 20 degrees C and an iron wire with resistance of 0.525 ohms at the same temperature. At what temperature their resistance is equal? Alright, when are their resistances equal? Well, resistance as a function of temperature goes as resistance at a particular temperature plus 1 times 1 plus alpha delta t, right? Okay, so what we need to look up here then, we don't know what delta t is, but we know where we start out, and we need this constant alpha for each material, which is a temperature coefficient of resistivity, right? And we want these resistances to be equal. So we want R copper times 1 plus alpha copper times whatever the change in temperature is to be equal to R iron, right, times 1 plus alpha for iron, the temperature coefficient of resistivity, delta T. Okay, so we know where we start out, right? We start out with R copper. Copper is 0.500 ohms. And we have our iron is 0.525 ohms. All right, we have to look up the coefficients. Alpha of copper is 3.9 times 10 to the minus 3 per degree C. 3.9 10 to the minus 3, and that is in per C. Degree C. All right. And for iron is, from the table, 5 times 10 to the minus 3rd per degree C. Okay? All right. So, and what we're after is delta T. If we manipulate this equation up here to isolate delta T, we start by just multiplying through our copper and our iron. I'm just going to start by copying everything and then make the manipulations. All right, so we're going to multiply through the R copper, and that means we end up with oh, come on, let me do what I want to do. All right, we end up with R copper plus R copper times alpha for copper times delta T. All right, that's what we get on one side. And on the other side, we end up with R of iron plus R of iron times alpha of iron delta T, right? Okay, so I'm going to subtract R copper from both sides, and I'm going to subtract R iron, alpha iron, delta T from both sides, and that's going to give us R copper, alpha copper, delta T minus R iron, alpha iron, delta T equals R of iron minus R of copper. Now, on this side, on the left-hand side, if I want to isolate delta T, all I have to do is factor it out. Right, so let me just copy this, see if I can't manage to. So I factor it out. It comes out of both terms and becomes a multiplier times everything. And now I just divide by this expression in the brackets, and I've got my equation I need, right? Go up here, grab that. Okay, so this is the equation for the change in temperature. All right, and if we stick everything in, we've got delta T equals 0.5 ohms, 0.525 ohms minus 0.5 ohms divided by 0.5 ohms times 3.9 times 10 to the minus third per degree C minus 0.525 ohms times 5 times 10 to the minus third per degree C. All right. Let's see if we can actually manage to calculate this. I'm going to do the numerator and denominator separately. 0.525 minus 0.5. Okay, denominator. 0.5 times 3.9 e minus 3 minus 0.525 times 5 e to the minus 3. Need an equal sign. All right, so equals the ratio of those two, minus 37. So delta T is minus 37 degrees C. That means we need to get to a target temperature of, we start off at 20 degrees C, so we need to get to minus 17 degrees C. And that would be it for problem 36.